Hello, my name is Stevetus and this is my course for the MCscript programming language. You'll hopefully learn everything about MCscript and how to use it during this video series. But first, let's take a brief look at what does it do. You may know the data packs for Minecraft. Well, these are just some files containing a list of commands, kinda like chained command blocks. But what if we turn this one-dimensional list into a logical structure and encapsulate certain things to avoid the ongoing repetition? Well, Minecraftserver aims to do that and gives you a ton of new tools to achieve it. This makes it for the developer faster, easier to read and more functional. There is, for example, special tooling for file generation, loops, groups and raycasting. MCscript actually ships in a few different variants. There is an online editor which also automatically compiles your code. So if you just want to try MCscript and don't want to install anything yet, this is your choice. But it has major fallbacks. For example, you need an online connection, the files are not directly loaded into Minecraft and some features are not accessible. An alternative is the desktop editor by Minimine, where you are able to directly compile it and reload the datapack from within the editor. This is just in very early development. There's also an experimental Java edition, so no need to install anything here, but it handles some things very differently to the usual JavaScript version. And this is the most common one, MCscript for Node.js. Node.js is a virtual executor that enables you to run JavaScript natively on your desktop. This is the main version and has most of the features like command line access, hot reload and datapack generation. But we will cover how to install this version in the next video along with plugins for text editors and start our own project. Therefore we will start with simple text output, go through block manipulation and block detection, and later on the course we get a bit more advanced and use raycasting and different methods to do, for example, this draggable platform right here. In the next section we'll take a look at the installation process and the setup of the required tools. As said in a previous section, there are multiple variants of MCscript, and I will focus on the Node.js version because it has the most features. So what do we need? Well, because it is a Node.js package, we need the Node.js runtime so your computer can execute JavaScript natively, and also the Node package manager, short npm. And then we'll take a look at how to install MCscript and also get the first text editor so we can edit the files with custom plugins, and we'll also take a look at a sample world and a first data pack. But first off we want to install Node.js, and therefore we go to nodejs.org. All links are also in the description, and we can go to the download section and choose our system. In my case it's a Windows system, so I will download the 64-bit version of Node.js. We'll just save the file, and once it is downloaded we can just execute it. This is a installer, so we just have to follow the setup wizard here. So we'll just say next, accept of course the license agreement, and install the whole thing into our program files, and just click next and install. So after you enter your admin password, it installs Node.js, and this could take a while. Meanwhile we can create a new world, so just click create new world. I'll name it MCscript, and of course cheats have to be on, and create a new super flat world. And once the world is loaded, we can immediately exit it again and click on the world and say edit. One thing I didn't mention so far, MCscript is for Minecraft 1.13 and 1.14, so you have to have these versions. In my case, this is the latest snapshot. So once we're in the Edit World menu, we click just Open World Folder. And inside this world folder we have another folder called Data Packs. And this is where we create our new data pack soon. Let's open our terminal in the Data Packs folder. You do that by holding the Shift key and the right mouse button. And there's the option Open PowerShell window or Open CMD right here. We'll use PowerShell, and that looks similar to this right here. This is the command line interface, and we are currently in the Data Packs folder. Now we can just type node-v, and that will give us the version of Node. If it doesn't display the version right here, try to restart your computer and try it again. Also, the npm command is available, so we can also do npm-v, and that will give us the version of the Node package manager. And we will also use the Node package manager to install MCscript. We just do it by npm install-g, that means global. So it is not just in the Data Packs folder available, but on your whole system. And then we just say MCscript. So the command is npm install-g MCscript, and that will install MCscript, and the current version 0.2.1 is installed. This might be different for you. And now we can just use the MCscript command, and we can also take a look at the documentation, also available in the description. And you can see the section CLI commands, and here are all the commands available in this terminal. We will use the MCscript new command. Let's type it in here, and then we have to define our name of our new project. I'll just call it test, and we can hit enter, and it generated some files here. And if you take a look at the Data Packs folder again, here is a new data pack called test, and all the necessary files and functions are already there. And we have also a new scripts folder along with the function folder. And in here we have 2 MCscript files already. We can just open them in the editor, but this does not look very nice. There are a few plugins for major text editors like Notepad++, Atom, and Visual Studio Code that highlight some information in here and give you a bit more tools to work with MCscript than the Notepad. So we will also install Visual Studio Code from this website here. Just download it. And we can also execute that installer. Let's go to next. Yes, accept it. Install it here. Create a shortcut. Yeah, that looks right, and install. And now we have this really nice editor right here. And right in our PowerShell window, we can also say code dot, and this will open our project for us. So we have our text editor. Now we need the plugin for this. And we just go to the extension tab right here. That is this icon. And we can just search MCscript. You'll see Minecraftserver language support. That is my plugin. And you can just hit install. And now you have it in your editor. And if we now open a script file, we can already see some things are highlighted here. For those who want to work in Atom, you can totally do that. And there's also a plugin by Trojana HD. And here you can install it by going into the settings and click on install here. And we can also search MCscript here. And it's this one right here, just hit install. And this should be similar to the Visual Studio Code edition. But throughout this course we will use Visual Studio Code because it has some handy tools. For those who want to be very basic, there's also the Notepad++ file on my GitHub, so you can also use that. But let's get started and write our first program, and we'll just open the load.mcscript file here. So let's just write log and then these double quotes here, and let's say hello MCscript. So you can also already guess what it does. It just logs this message to the chat, and we can save it with Ctrl S and open our PowerShell again, and we can just say cd whatever name the data pack is, and that will just say, yo, we want to go into that folder. So we just go with our console in this folder, and here we can say MCscript compile. This will just say that it read 3 files and it generated also the MC functions right here. In Visual Studio Code, we see a main function, a load function, and also this MCscript folder. We will explore in the following sections what these are. But if we enter the vault and hit reload, we can see the console statement and the hello MCscript. That's it for this section. We successfully installed MCscript and created our first program. In this section, we'll take a deeper look at the structure of our generated project and also how we can add new files and actually generate files with MCscript. In the last section, we set up our environment and already generated a first project. It's also a data pack, so it has the data folder inside of it, and this custom namespace here is also the same with normal data packs, and that is another folder inside our data folder. There we have the function folder, and for MCscript we also have a scripts folder. In the functions folder are obviously the MC function files that get actually loaded into Minecraft. And in the scripts files are our new MCscript files, which actually generate our MC function files. So ideally, we just added the MCscript files. So here I have my PowerShell again, and we are again in our data pack. And here I can just do MCscript compile, and it will compile our entire project. What we can also do is say new file right here and name it test.mcscript. So this is also in the test folder right now. And here we can also say log hello, and it should compile now 4 files with our test.mc function. And the test.mc function is not loaded into the functions folder because it was not found in the scripts folder. Everything that is in the scripts folder gets compiled in the functions folder, but everything else is just moved in the same location. And here in the MC functions file, we can now see from where it got compiled from our test.mcscript to our MC function. And we see also our tailraw command again for the console. It could also be the case that you want just one file to compile, and you can also do that by putting in the path to a single MCscript file or folder, and it just read one file. But we will work with our project, and I will delete these files again. In our main.mc function we can see this annotation right here. So it is #file column.main, and this just says MCscript, hey, I want to compile the content of this MCscript file here into the same location. It is not scripts in this case, but functions. And I want to call this new file main. And exactly that is done. There is this new main.mc function created in the functions folder. Of course, you can also leave this part out, and MCscript will also automatically get the original file name from the MCscript file. Just take the main part in this case and transfer it to an MC function. And if we were to delete this main.mc function and save it here, the main.mc function is still created. So in this case, this is optional, but it is, as always, recommended. So let's create a new scripts file here. I'll just name it files.mcscript, and I can say file column and then the path to our new MC function file. This means always in the same folder. This means one file above our folder. So in our case, this would be this test folder. And we can also insert a new folder here. Let's call it files, and also main inside this files. Now if we compile it, we can see this new main.mc function is created inside a new folder called files. And we can also see that in Visual Studio Code, there's this new file folder here. We also noticed this MCscript folder inside of here, and that is just used by MCscript internally to load a few components later on. And in our load.mc function, this is automatically added, the MCscript load right here. And we also configured our load.mc function and main.mc function as the load and the tick functions. So this main runs 20 times a second each tick, and this here on the initial load. But back to our files, we can just insert a command here, say, hey, every command is announced with a slash, a bit different to the MC functions files. You can also use run column that does the same, but slash is obviously faster. So what we also can do, since I don't want to run MCscript compile each time, we can just say MCscript watch. And now we can see the program does not exit, and it says now watch your files on this path to change. And now if we change this file here and hit Ctrl S to save it, we can see in our PowerShell it automatically ran the command MCscript compile and generated all our MC function files, so we don't have to worry about our compilation. So in our files.mcscript we can also insert a new file. We'll also put it into the files directory and name it second and say second. We can see a new file second.mc function where it says second. So why am I telling you this? Well, you can define multiple files inside one MCscript file and you can just generate them. But let's imagine you have multiple files here, and at some time you notice, wait a moment, I'm in the second file, but I want to add actually something into the main function again. Well, you can just do this file again and copy everything what's already in there and say hello to, but this is not the right way to do it. MCscript also covers that. We can just say extend, and that will just add everything below here at the back of our main file. We can save it and take a look at our file's main, and then we can see say hello and also this annotation extended from files.mcscript to main.mc function with say hello to. So now I want to show you a feature that is very handy with the file generation, and that is the generative for loop. The generative for loop is not just for file generation, but for generation in general. And I called it generative because it is run when you compile it. So it just generates the MC function code and not a for loop inside of Minecraft. The syntax is relatively simple. You just say for, then we have some brackets, and inside of that two numbers, from and to, and that just defines the range of our counter. And we can also optionally put in a name for our counter variable, which we can then use with this $sign and the brackets again. This might be a bit confusing right now. We'll see it in action. So we saw it was defined with a for, then some brackets, and then a minimum value, say 1, and a maximum value 5. It will just go for each value between 1 and 5 and will insert this bit right here into our code. So we can say value, and we can see it is inserted 5 times here because we wanted to go from 1 to 2 to 3 to 4 to 5. That's 5 times. We can also insert our current value in here with the $sign and the brackets. By default, this value is called I for index, and we can see in the main.mc function there's value 1 to value 5. We can also define our custom name here. Let's name it counter. And now if we compile it, it just says $sign I. So we also have to change our counter variable inside of here, and we get also the same result. So why is this such powerful in combination with our file syntax? Well, we can also say file in here. And here we can also insert our value, change it back to I and remove the counter here. And then we can say hey. What this will do for us now is it will generate 5 files with the name 1 to 5, each with the content say hey. And there we have it. There are 5 MC function files. In our MCscript file we can just change one thing here and it is changed in all our generated files. And we can also say I want to have 500 files. That's also totally possible. And now we have 500 files with this bit of code, but certainly I don't want 500 files, so I will just delete this folder here and change it back to 5. We have our 5 files again. So now we already dug a bit deeper into the file syntax. By the way, in Visual Studio Code we have also the snippets enabled. It will suggest you what you could want, and it will give you simple documentation from to variable name. You can just say tab, insert your first value, press tab again, insert your second value, and insert your command, whatever. So this is also pretty handy. Now I want to show you an alternative way for this file syntax, because if you have many files, this is really annoying because you have to extend it again. So let's say I want to have here another file. Well, that is not that simple. Well, you can do that, but this hello will now be in this function file and not in the main file. So therefore we have the function annotation, and this just generates a new function, but without this annoying syntax, with a clear restriction. So we have this opening bracket and this closing bracket, and everything else is not included in this function. You can also set the run keyword in front of it, and it will automatically run the function, analyze your project and get the namespace for your data pack and directly insert it. So let's take a look at that. We can just say function and then our path. This will be files function and then these brackets again. And in here we can say this is the function, and here we can say this is the main. So what I expect is that this content right here is inserted into the main file, and this content in brackets here is inserted in the function file. What I forgot, if you want to insert a path here, you have to set it into these quotations. And now there is a brand new function.mc function here, and it says this is the function, and in the main function it says this is the main. But you can also leave these quotations. You just name it function file, for example. But what if we want to run this function directly from within the main function? Then we can just say run function, and in our main.mc function we can see this new function, and it automatically analyzed our project and extracted our data pack ID or the namespace and the path of the function. So now inside Minecraft we can run the function test files/main, and we can see this is the function and this is the main. Of course the function is called before the this is main. So I hope this section gave you a insight into the file generation in general, and it helps your workflow, especially for boss bars where you need several of them. This for syntax is also pretty helpful. In the next section we'll take a look at
constants, groups, and also conditions, so if and else statements. In the last section we looked at this for loop here, and we already used this notation here, $i, to replace this whole thing with the current index. So that is actually a constant, and constants are replaced on generation, so they can't be changed while the data pack is loaded. And you also can't assign new values to any constants. This for loop gives you a predefined constant, but of course you can also define your own constant. That would look something like that, just with the const keyword, then the name of the constant, an equal sign, and then either a string or also a number. And later on you can just use it in any command you want. In the say command we use the a string constant, so this one here, and it just replaces this whole thing here with our say here can be a string. The number can also be used in the command, so we can say level equals a num, and it replaces the level here. This is pretty easy, right? We can actually use this, and let's say we want this part here in a separate constant. It is always recommended to define them first. So we just use the const keyword, then the name, let's say main text equals, this is the main, and we can also define a thing for the function. This is the function. Then we can replace this here and just copy it in here and do the same for our main. I just noticed my font size was a bit small, and also this has to be a string obviously, and we have to put quotes around it to define that. Now we can save it, and we can see in the main.mc function, say this is the main, and say this is the function. What we can also do with constants, we can replace some parts of it. So let's say we have the a string again, and we can just say dot repl, the thing we want to match, and replace it. In the end it generates from here can be a string to here can be this string. And this match thing here can also be a regex for already professional programmers out there. The next thing in this section is the group, and that's just a simple way to group execute subcommands together. Oftentimes you come up with /execute as at p as at s multiple times with multiple commands, and there it makes sense to group the entire thing together and avoid repetition. So we can just use the keywords as, at, positioned, and some squirrely braces, and then all the commands in there that we want to execute. And we can also list multiple groups into one whole group just with a comma here. Let's also do that in the main.MCscript. We want the player's position here. So we just say as, at a, then a comma, and say at s, and then our brackets here. And inside of here we can run our commands. Let's just set a block at the current position to a redstone block. And maybe it's better 2 positions above. So we can save it and take a look at the main.mc function. And there's a command that looks similar what you would also write. In Minecraft we can actually do a reload. Every tick there is a block placed above us. And of course we can also use multiple other functions of MCscript in these brackets here. We can also nest other groups inside of here, so we can just say positioned. My extension actually gives you a few snippets. So these things already autocomplete, we can just say enter the position here. This has to be a string, and then we can move this command in here. Of course it does not make sense for one command to use this entire block of code here, but imagine you would write many commands in here. And with many commands this would not be performant, so let's say run function player And this just generates a new function for that, outsources the commands. Groups are of course available for all execute subcommands. You can take a deeper look at this at my documentation on stevetus.com/MCscript. But let's continue with the condition part. This is very similar to the groups. It also generates an execute command. In this case, execute if. And so far it looks very similar. You can also negate them. You can put an exclamation mark in front of it, and that will just turn the if to an unless. And we have also the else statement. So if this one up here is not true, the else will trigger. And we can also use the else if statement to test another thing. And that would just generate a new command where the first condition is negated and the second not. And then we can also use an else statement, and that would generate a command where both of the conditions are negated. So let's use this knowledge in our project. If you've seen the course overview, we had some great speed and jump blocks, and I want to start making them. So obviously we have to test if the block is under us. In our case we take the orange concrete for the speed block. So we just say if and then a string in here, and that would be the normal condition you would write after an execute if. So that would be block, obviously underneath the player, and we want to have orange concrete, and then we want to give our current player an effect called speed for 1 second without particles. Let's do also the jump boost. Here we want to use lime concrete, and we also want to give the player an effect. Jump boost, again for 1 second, but only with the power 3. So let's save that. In our new player.mc function, we can see our two commands with the effect, and we can right away test it in Minecraft. So let's reload the game, and on orange concrete we get a speed effect, and the green concrete just gives us jump boost.
In the fifth section, we'll take a look at booleans, variables, as well as raycasting. And we'll also wrap up our project and finish this course. So let's start directly. Let's take a look at the boolean first. And the boolean value is kind of like a switch. It can be either on or off, so it can just have two states. And in Minecraft you would usually implement this as a tag. So tag add is true, and this would mean we have a true state. And then we can check on the entity if the entity has the specific tag or not. But this can get very confusing long term. So in MCscript we have the bool keyword, and like constants you give it a name. So if is true, and you also have to set it to a default value. So let's set this to true. And MCscript just takes this here, and it will generate one entity that holds all the boolean values as tags and determines the state. What you can also do is after the name you can input a selector, and that will add the isTrue tag to @s. So if you take a look at the main.mc function, we can see this just translates into a tag. And we can also easily check for that tag. We just say if is true, and then we can execute something. I don't know, log true or something. And here as well we can include our selector, and this will just check if this boolean value is present on our selector. So now that we know about the boolean, we actually want to do something with this. And you might remember from the beginning this pink wall here, and this should be a wall running wall. We can just come near it and we can run across the wall here. So we want a boolean first that determines if the player is near a wall. So we say is wall @s equals false, and we'll also put this into the player function. And if is wall is true on @s, then we will set is wall add s to false again. And also before that, we just check if a block is under us. So if there is no block, we can set a new block, and this would be the barrier in our case. So you can't see that. So just set block barrier. And every tick, we also want to clear these barriers as well. So we just say fill in a 4x4 area around the player the barriers to air. So now we determined what should happen when the is wall is true. But we actually have to trigger it. So to detect if a block is near us, we use a similar method to this one here. We will just check around the player in this cross movement here if there is this pink block. And if there is a pink block, we set the value to true. Well, that sounds simple, but it is actually a bit more complicated because you have to do it for each and every position here. I copy it in here. You can see this is literally just a execute, and it checks for every possible block around the player and just adds our is wall tag. And this of course also affects our Boolean here. Let's reload our game. And you can see now if we approach this wall here and we are one block away, we just stick to the wall, and you can also see the barrier block under the player here. The other thing I wanted to talk about are the variables. With this Boolean value, you can already save values. It is really just restricted to these two values, and we also want to save numbers. And we can do that with the variable. Before we use the variable anywhere, we have to declare it, and it's just var, and then again a name. So let's name it test. In the MCscript load function, you can see this scoreboard is automatically added, and you don't have to deal with that. And to this variable, you can assign a value. You can either do that here, so let's set this to 10, or you can also do that after it. You can now use the test everywhere in your file, and you can also always change it. And of course, you also have the selector here, so you can, just like a Boolean, write the select after the variable name, and this will just set the variable of this selector to this value. And because it is a scoreboard, you can just run all the usual scoreboard operations on it. So for example, scoreboard players get just works like normal, but MCscript also adds something on top. So for example, if you want to increase the value by a given number, you can just use this operator here, and let's increase it by 1. If you want to increase it or decrease it by 1, you can also use a short syntax, just test ++ or ---. And we can also work with multiple values. So let's define a new variable here, and let's set this to 16. And now we can say test should multiply with new. So that is this operator here. And you can also say test -new. All of this is possible. And this will again be saved in the test variable. One other special thing is you can set the test value, for example of @s, to a command result. So we just say equals run column and then your command. So for example, a simple data get command. Why do we need it for our project? Well, our end goal is to move a boat by clicking on it, and somehow we have to detect this clicking. We just do that with a carrot on a stick, because you can really easy right click it, and it will also be registered as an item use event. So if we set scoreboard objectives add click, for example, and then we can set Minecraft.used carrot on a stick. That way we can save the amount of clicks on a carrot on a stick in a scoreboard. This is done by Minecraft automatically. So let's define this scoreboard first. So we just say var click, and you can now see this is added to the load.mc function. But it also has the type dummy, and we want this Minecraft.used, and that means we have to define our scoreboard ourselves. And to prevent this auto generation of this scoreboard, we can just say no ! Before the name, and MCscript will recognize that you define the scoreboard yourself. So let's do that in the load.mc function. And here we just copy in our command that we typed with the Minecraft.used. And if you've done everything right, we can now set the sidebar to click. And if we click it, you can see this increases. And we can use that to detect our click event. So let's go back into the main.MCscript, right in the bottom of our player function. And here we say the click on our selected entity, so every player in the world, is bigger than 0. So if the player at least clicked once, and this is also a convenient way to implement the if here. You can use all kinds of comparison operators here, for example, 2 equal signs for equal, greater than, greater or equal, and so on. But we'll stick with this for now. And then we just want to call a function, test column click. We will create this function in a minute. And we also want to reset our click variable again, so we just set it to 0 again. Let's create a new script here, new file, click.mcscript, and we just define the file here, click, and let's just log it for now, so we can make sure that it works. After we reloaded it, you can see right away it is set to 0, and when we click it, you can see the console right here, and it seems to work. So in this click file, we now want to test raycasting. And raycasting is just a term that means to select things that you're looking at. So we can just use raycast here. If you have the Visual Studio Code add-on installed, you also have this snippet here, and it goes in these curly braces here. And in here we can insert an operation that should be applied to the block that we are looking at. So we can, for example, set block the current position to stone. So now that we reloaded this, we can now click anywhere and it turns into this stone here. Initially I prepared a fancy animation for this, but now we have to take a look at the documentation here to discover the raycasting more. So like you can see here, this looks a bit more complicated than what we used, because you can actually insert options here. And these options are all optional, you can also see that here. And the first option is the maximum distance. By default this is set to 100 blocks. As second option, separated with a comma, you can set the block or the block tag to travel through. So you have to imagine there is a ray sent from the player's position into the direction the player is looking. And with this block option here, you can just say which blocks are solid and which are not. And as third option, you can set either entity or block, and that will be the target. For example, you choose the entity mode and check for a pick. Then only if you're looking at a pick directly, this will trigger. And you can set what will trigger in this block here. And here you can insert commands or other components of the MCscript language. And optionally, you can insert a comma and another squarely braces block. And you can execute stuff for every step. So this ray is not instantly at the position, but it actually steps through all the positions until it hits a block. And here you can do, for example, particles. Down here there are also the defaults for the block and the target. So like you can see in Minecraft, this hits any block in the game. So then let us upgrade this raycasting a bit more. And we say for every step, that's the second block here, we want to display a particle, but also not on the entire world, but just in a range of 5 blocks. So we say if at s is at a distance 5 blocks or more, and then we can display a particle. So in that way we don't just block the view of the player. So now if we shoot a bit further, you can see this ray a bit more, and you can see how it works. How does this help to move a platform? Well, we could just raycast to the entity, that's the platform, and move it a bit. But we also want it just on this line here. That means we have to detect some way if the entity is on this line and you click on it with the caret on a stick. This is quite tricky, but I had an idea. What if we take just some glass blocks, like gray stained glass, and hide it under the ground here, just like that. And if we click this caret on a stick here, we just check every time if this glass block is at this certain height here. If it is, and the entity is also near, we can move that entity. If this sounds a bit odd to you, yes it is, but once we implement it, it will be a bit more clear. So our glass blocks are at the height 54, and we can just check every step of this raycasting. If there is a block at the current position, but at the height of 54 blocks. So just gray stained glass here. And if we take a look at the generated functions a bit, we can see that this works with the MCscript stop tag. And this is basically a way to say if the entity has this tag, the raycasting is complete and we'll execute this part up here. So we can just simulate this hit by adding this tag manually. We'll just say tag add as add MCscript stop. So in that way we should not be able to shoot over the glass. So now let's see if we aim at this invisible wall now with the glass blocks down there, we can see it stops right there. And it's like a wall that we can paint on. And it's also pretty dynamic because we can change these blocks down here and it will change the hit area. But we don't want to place blocks there, we want to move a platform. And to implement this platform, you have to be a bit creative for that. Of course, with resource packs and models you can do much more. But I picked a boat for it, because a boat actually has a hitbox to stand on. To give it a bit more flat space, I included some passengers. So there are just like 2 static turtles in there to give it a platform. I would say let's create a new script to summon this entity. Summon.mcscript, trigger this manually, so no need for some interaction here. But we want to align it, so we just use align X, Y and Z, and then just copy our command in here. So let's execute our command at this position. And yes, it was pushed into the corner a bit. So let's change that quickly by adding 0.5. And now if we run it again, we can see it is perfectly centered and we can just stand on it. This would be perfect for a 2-player game where the one controls this platform and the other stands on the platform and gets moved by the other player. But let's implement the technique to move this boat here. Therefore I have given the boat a special tag, target, so we can select it in here more easily. And the easiest thing would probably be to just check for the entity. So for example, as at E with the tag of target at a distance 2 blocks, and then we can just TP that entity to the current location where the Raycast hit. And yes, kinda works, but it also works vertically, and we don't really want it. Of course, this is a simple solution, you can totally do that, but because we are using TP as well, this is limited to 20 frames a second, so it's pretty unsmooth. And we also want to work with a bit of NBT data as well, so let's use the motion NBT data for that. First we have to define 2 scoreboards. For at E tag equals target, and the same for the Z axis. And then we have to test for all directions of our hit point, like we did that with our pink wall. So let's remove that here. And we want to see if our boat is in that direction. And depending on how far it is from our hit point, we want to increase the motion so that the boat in the end moves. Let's do that for the x-axis first, x, and we also want to position it 0.5, so right in the middle at the same height, and 0.7 to give it a bit more room. Because we have the x-axis, we want to modify the z-axis on there. So at E, which has the tag of target and is in a distance of 0.6 or lower, because we used the 0.7 up here. And we just want to increase it by 1. And this has to be done for all 4 directions. I will do that quickly, we'll see it in a second. So here it is, aligned to the x-axis and moved in the z-axis, positive and negative, and the same for the x-axis here, where we modify the motion x. So now we have a new motion value in the scoreboard here, and now we want to save it into the entity. That means we select the entity again, at E, tag equals target, at a distance of minimum 5 blocks, and then we want to execute, store the result into an entity, at S in this case, and the motion 0. This is a double, and we also scale it a bit down. And then we just run forward players get, which you can't see at the moment, but it's there. And the same goes for the 1 motion, but we have to change this obviously to Z right here. So this would be it for the code. Again, what we do, we send out a ray. The ray goes from the player to the block that the player is looking at. And for each step between that, we show this flame particle. And if there is somewhere a gray stained glass at the height of 54, we stop the raycasting and it enters this block here, where we modify the motion of the boat if it is at a specific distance. So let's test that with a brand new entity, and we will take our carrot on a stick. And here we can now see if we aim at it, it moves slightly and a lot smoother than the other variant. And that way we can control this platform right here. So this would be it for this course right here. Of course, there are so many more things in MCscript to explore, but I think you understood the basics. This was it for this MCscript course. I hope you liked it. We'll see us soon.